Welcome friends, my name is Ranvir Abhay B.Sc. studying in B.Sc second year from Adarsh College Hingoli. Today we discuss about theorem of integrability of the sum of integrable functions. Now we see statement if f1 and f2 are two bounded and integrable function on closed interval a, b, then f is equal to f1 plus f2 is also integrable on closed interval a, b, and integration of f1 dx from a to b plus integration of f2 dx from a to b is equal to integration of f dx from a to b. Clearly f is bounded on closed interval a, b. Now we see proof. Let p be any partition of closed interval a, b and capital M dash I, small m dash I, capital M double dash I, small m double dash I, capital Mi, small mi be the bounds of f1, f2 and f respectively in delta xi. Therefore, small m dash I plus small m double dash I less than equal to small mi less than equal to capital Mi less than equal to capital M dash I plus capital M double dash I. Consider it as equation number first. Multiplying by delta xi and adding all inequalities for I is equal to 1, 2, 3, 4 up to n, we get lower sum of function f1 plus lower sum of function f2 less than equal to lower sum of function f less than equal to upper sum of function f less than equal to upper sum of function f1 plus upper sum of function f2. Consider it as equation number second. Let epsilon be any positive number. Since f1 f2 are integrable, therefore we can choose delta greater than 0 such that for any partition p with norm mu of p less than delta, we have upper sum of function f1 minus lower sum of function f1 less than epsilon by 2, upper sum of function f2 minus lower sum of function f2 less than epsilon by 2. Consider it as equation number 3. Thus, for partition P with norm mu of P less than delta, we have from equation number 2 and 3 upper sum of function f minus lower sum of function f less than equal to upper sum of function f1 plus upper sum of function f2 minus lower sum of function f1 minus lower sum of function f2 less than epsilon by 2 plus epsilon by 2, which is equal to epsilon. Thus, the function f is integrable. Now we proceed to prove the second part. Since f1 and f2 are integrable and epsilon is any positive number, therefore by Darboux theorem there exists delta greater than 0. We have upper sum of function f1 less than integration of f1 dx from a to b plus epsilon by 2 and upper sum of function f2 less than integration of f2 dx from a to b plus epsilon by 2. Consider it as equation number 4. Also, integration of f dx from a to b less than equal to upper sum of function f. By using equation number second, we can write as it is less than equal to upper sum of function f1 plus upper sum of function f2 less than integration of f1 dx from a to b plus integration of f2 dx from a to b plus epsilon. Since epsilon is arbitrary, we conclude that integration of f dx from a to b less than equal to integration of f1 dx from a to b plus integration of f2 dx from a to b. Consider it as equation number 5. Proceeding with minus f1 minus f2 in place of f1 f2 respectively, we get integration of minus f dx from a to b less than equal to integration of minus f1 dx from a to b plus integration of minus f2 dx from a to b, or integration of f dx from a to b is greater than and equal to integration of f1 dx from a to b plus integration of f2 dx from a to b. Consider it as equation number 6. From equation 5 and 6, we get integration of f dx from a to b is equal to integration of f1 dx from a to b plus integration of f2 dx from a to b. Hence proved. Thank you friend for watching.